Okay, this is lesson 10.4, part 1. And for part 1, we're doing ellipses with center at 0, 0. So let's start by looking at two ellipses and looking at some of the parts of an ellipse. So first of all, notice that there's always a longer side and a shorter side. If there isn't, if both are equal, then we have a circle. So the longer side is always called the major axis. So in this situation, we're going to have a horizontal major axis. This is my major axis, and my shorter axis is called my minor axis. And the ellipse always has two foci, and they always go along the major axis. I don't want that arrow pointing right there. I'm going to move that a little bit. That might be confusing. So I'll call this one F1, this one F2. Now, the endpoints here on the major axis are called my vertices. Okay, and the distance from center to vertex is distance A. So this coordinate I'm going to label A0. And once again, the distance from center to vertex is A. So I'm going to label this point negative A0. Now these two, the two endpoints on my minor axis, those are called co-vertices. And the distance from center to co-vertex is B. So I will call this 0B and 0, negative B. Okay. And you know, I'm going to write that down, the A and B. So let's put that up here. A equals the distance from center to vertex distance from center to vertex, and B equals distance from center to co-vertex. Distance from center to co-vertex. Let me get my hand out of the way. Right, so let's fill this in. Each fixed point F is a focus. Each fixed point F is a focus of an ellipse. The plural of focus is foci. And an ellipse always has two foci, once again, and they're always on the major axis. So for this ellipse, my major axis is vertical, and my foci lie on my major axis. So I'll put them in here. I'll call this one F1 and this one F2. And so major axis, minor axis, distance from center to vertex is A, so I will label this 0, a, and 0, negative a. Distance from the center to co-vertex is b. So I'll label this negative b 0 and b 0. So next we have a standard form of an ellipse with center at the origin. So there's two equations depending on where your major axis is. So if your major axis is horizontal, then it's x squared over a squared plus y squared over b squared, and it always equals 1. The equation of an ellipse always equals 1. Now, in this case, since my major axis is vertical, the only thing that changes is my a and b. So now it's x squared over b squared plus, always plus, y squared over a squared, and always equals 1. So these are my standard forms. So just notice that a goes with the major axis. So in this case, once again, major axis is horizontal. My vertices are plus and minus a, comma, 0. And my co-vertices are 0, plus or minus b. Now for this one, my major axis, vertical. My vertices, which always fall on the major axis, are going to be 0, plus or minus a. And my co-vertices, plus or minus b, 0. This is a little hard to read. I'm going to erase that. Try again. So I want this to say b, 0. So let's write some characteristics of the major axis, minor axis, what they have in common, what's different. So the major axis is the longer axis. Right? The minor axis is the shorter axis. On the major axis, the endpoints are vertices. Endpoints are vertices. On the shorter axis, the endpoints are co-vertices. Endpoints are co-vertices. And the major axis always contains the foci. The minor axis is always perpendicular to the major axis. So perpendicular sign, perpendicular to the major axis. Now the center of the ellipse is always the midpoint for both. So I'll just write center is the midpoint for both. Alright, let's try an example. Okay, write an equation in standard form of an ellipse that has a vertex at 0, 5, a co-vertex at 2, 0, and a center at the origin. So my first step, as usual, will be to draw a picture. So my vertex is at 0, 5, 2, 3, 4, 5. And once again, my center is at the origin, so I have another vertex at 0, negative 5. 1, 2, 3. 2, 3, 4, 5. Okay. Co-vertex at 2, 0. So that means I have another one over here. Okay, so there's my ellipse. Draw a bad ellipse. So I'm writing an equation in standard form, which means I need A and B. So A is the distance from the center to a vertex. A equals 5. B is the distance from center to co-vertex. B equals 2. And now I can just write my equation. X squared, that's over B squared. So X squared over B squared plus Y squared over A squared equals 1. So that's X squared, B squared is the same thing as 2 squared, X squared over 4 plus Y squared over A squared, 5 squared equals 25 equals 1. Okay, let's try another. Write an equation in standard form of an ellipse that has a vertex at 6, 0, a co-vertex at 0, negative 3, and a center at the origin. Center at the origin, vertex at 6, 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, co-vertex at 0, negative 3, I'm going to sketch my ellipse. It's pretty bad. That's worse than the other one. So I'm going to use my same thing here, x squared over b squared plus y squared over a squared, except it's going to change a little bit. So now it's x squared. This time it's over a squared, because this time my major axis is horizontal. So now I'm going to do x squared over a squared plus y squared over b squared equals 1. Always equals 1. A is the distance from center to vertex. A equals 6. So it's x squared over 6 squared plus y squared over 3 squared. B equals 3. Distance from center to co-vertex. Come up. So I have, equals 1. That's important. X squared over 36. And then once again, I'm going to say it's always, for ellipses, it's always plus. Y squared over 9 equals 1. turn to the next page. Okay, so now it says, find the equation of an ellipse centered at the origin that is 12 units wide and 30 units high. So if my ellipse is centered at the origin, if it's 12 units wide, it's going to be 6 units on each side of the origin. And let's see here, since I'm going all the way to 30, I'll go by 2s. So 2 here, 2 here. Go 2, 4, 6, we'll go out to 8. 2, 4, 6, 8. Right, so I'm going to go out 6 units on each side. So that's 6 here, negative 6 here. So there's that. And then it's 30 units high. So that means it's going to be 15 units above the origin and 15 units below the origin. I don't think I made my grid big enough. And this doesn't have to be perfect. This is just a guide to help me. But nonetheless, I want more space. Let me try that again. So 2, 4, 6, 8, 10, 12, 14, 16. 2, I'm going to make that 2 so I know my scale. 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 2, 4, 6, 8. Let me try again. So you want to label as 2 and 2 so you know your scale. So I'm going to go split once again. I'm going to start here again. 6 units in each direction. 2, 4, 6. 2, 4, 6. Those are my co-vertices. I'm going to go up 15, down 15. Which is right here, since I just counted it, and down here. Okay. So now I'm going to have x squared over b squared, minor x's, plus y squared over a squared equals 1. B is 6, a is 15. So I have x squared over 6 squared plus y squared over 15 squared equals 1. X squared over 36 plus y squared over 225 equals 1. Okay. Find the equation of an ellipse centered at the origin. What's that? That is 10 units wide and 6 units high. Ten units wide, that means 5 on each side. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6 units high, 3 up, 3 down. 1, 2, 3. 1, 2, 3. So, major axis goes horizontally along x. So it's going to be x squared over a squared plus y squared over b squared equals 1. And that's x squared over, and we said a is 5. 5 squared is 25. Plus y squared over So b is 3, so b squared is 9 equals 1. Okay, so now we're going to talk a little bit more about foci. So once again, the foci, I'm going to highlight this. Foci are always on the major axis. Let's keep going. It's units from the center. So C units from the center, so that means the distance from the center to the foci, or from the center to either focus, is C. So let's just write that one more time. C equals distance from, I'm going to write from center to foci. So it's the center, distance from the center to either focus. So it says there is an important and useful relationship among A, B, and C. You can use the relationship to find the foci of an ellipse. So the formula we're using is C squared equals A squared minus B squared. And I'm going to draw a little picture here. Here's an ellipse. This one happens to have a horizontal major axis. I'm going to draw my foci, F1, F2. Now the distance from the center to a focus is C. C. A little hard to see. One more time, distance from the center to the focus is C. But this is the formula we're going to use quite a bit. So we can find either one of the vertices or the focus depending on what the problem gives us. So for this example, find the foci of an ellipse with this equation and then graph it. So first thing is, when I have an equation of an ellipse, it has to be equal to 1. So that's the very first thing I'm going to do. So I have 25x squared plus 9y squared equals 225. I'm going to divide everything by 225, so I have 1. So 225, 225, 225. So I'm going to end up with, now 225 divided by 25 is 9, and 225 divided by 9 is 25. X squared over 9 plus y squared over 25 equals 1. So now I have enough information to find the foci and to graph. So this is the x squared over b squared plus y squared over a squared equals 1. Let me write that. X squared over b squared plus y squared over a squared equals 1. Put a little parentheses so we kind of remember what we're doing here. So I need to use this equation to find c, which will then help me find my foci. C squared equals a squared minus b squared. And I know that a squared is 25, and I know that b squared is 9. So c squared equals 25 minus 9. Which is 16. Square root of 16 is 4. C equals 4. Alright. So I have C. Now remember that we said a squared is 25. A squared equals 25. So that means that a is 5. And b squared equals 9. So that makes b 3. So I'm going to graph and then go back and find the foci. So A goes along my major axis, which in this case is the vertical. So I'm going to go 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 down. And then for x, I'm going to go left and right 3. From the origin. 1, 2, 3. 1, 2, 3. Okay. Now I'm going to find my foci. So the distance from center to focus is 4. So I'm going to go up 4 from the center. 1, 2, 3, 4. Okay, and I'll label that F. And down 4. 1, 2, 3, 4. F. So the coordinates of my foci are, let's write F for foci, are 0, 4, and 0, negative 4. So I graphed, I found the foci. Let's do one more. So this has to be equal to 1. X squared plus 9y squared equals 9. I'm going to divide everything by 9. So I have x squared over 9 plus just y squared just goes to 1 equals 1. So a squared equals 9, and b squared equals 1, because this is y squared over 1. So now I can find c by using my formula. C squared equals a squared minus b squared. C squared equals a squared minus b squared, which equals 9 minus 1, which equals 8. C squared equals 8. Come on up here. C equals the square root of 8, which is 2 rad 2. So I'll graph, then find the focus. So I'm going to go from the center, I'm going to go out 3 in either direction. Square root of 9. 1, 2, 3. 1, 2, 3. And I'm going to go out from, in the y direction, 1. That's y squared over 1. Alright. So I need to find this distance to radical 2. So just for graphing sake, that's approximately, if you put it into your calculator or estimate, it's about 2.8. And I'm only using this number for graphing. This is not going to be my answer anywhere. So 2.8. So that's about here. really, really close to the vertex. So what you might notice if you start graphing these is the closer together your foci are, the more your ellipse will start looking like a circle. Farther away they go, the longer it gets. So we're approaching maybe a circle and a line, I guess, stretching. So now all we need is to write the coordinates of those. So it's f focus, and it's just going to be 2 radical 2, 0, and negative 2 radical 2, 0. Don't write 2.8 comma 0. Use the real number. This is only good for graphing. Alright. Next it says, write an equation of the ellipse with foci at plus or minus 7, 0, and co-vertices at 0, plus or minus 6. So, as usual, I will start by sketching this. This is not asking for a graph, but I'm going to make one to help me. Foci plus or minus 7, 0, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay. And my co-vertices are at 0 and plus or minus 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I have C, the distance from center to focus. So C equals 7. And what else do I have? I have B, the distance from center to co-vertex. B equals 6. So now I can use my formula to find A. C squared equals A squared minus B squared. So 7 squared equals A squared minus 6 squared. 49 equals A squared minus 36. Add 36 to both sides. 85 equals A squared, and square root of 85 equals A. So I guess at this point I'm just going to draw this in. So square root of 85 is approximately 9.2. Let's write that in there. Yes, it's approximately 9.2. So where am I? I'm at 7. Take out a few more. 9, 10. 10. Okay, so there's my vertices. So now I'm just going to write my equation. So it's going to be x squared over a squared, because it's my major axis. In this case, a squared is 85, plus y squared over b squared, and b squared is 36, equals 1. Try one more. Write an equation of the ellipse with foci at 0, plus or minus rad 17, and co-vertices at plus or minus 8, 0. So I will sketch. So first thing, just to help me graph it, square root of 17, it's somewhere around 4.1. So we did 4.1. 1, 2, 3, 4, right in there. 1, 2, 3, 4. Okay, those are my foci. Hard to see. What else do I have? I have co-vertices at 8. 1, 2, 3, 4, 5, 6, 7, 8. And I already know that my major axis is going to be vertical because of where my foci are. So here's my co-vertices. So I know B equals 8, and I know C equals radical 17, and now I can find A. C squared equals A squared minus B squared. C squared equals 17, and B squared equals 64. So that means that I'm going to add 64 to both sides. That gives me 81 equals A squared. So 9 equals A. Let me graph that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Supposed to be round. So my equation is going to be x squared over b squared plus y squared over a squared equals 1. That is part 1 of section 10.4.